little bit more difficult function, which is exponential function. What do we mean by exponential function? Let's have a look. What is that? So here we have a function, and that 2.72 is taken to power, and that power has a letter. That's where my x is, or in this case t, independent variable. So that's what exponential is, when here in power I have letter. Let's not forget, always the same. X is between x and y, is just x and y can be called different letters. And in this case, that's what we have. X is not x, is t. Y is not y, is k. But it's always about those two axes. Again, let's have a look at what does x and y represent in the context of this question. The number of bacteria in a different experiment can be modeled by the function. So what does that represent? That is number of bacteria. So that's what this axis is about, number of bacteria. And then we have 3,000 multiplied by 2.72 to the power of 0.5, not 0.5. Let's remove that. 5. And what is T? K is the number of bacteria, and T is the time in hours since the start of the experiment. So multiply that by number of hours. So that's what I'm going to have here. My X is number of hours. That's what it is. Okay, so what do we need to do? And again, I'm just going to remind you, always remember, majority of your question is about X and Y. If they are looking for X, they gave you Y. If they are looking for Y, they have given you X. We just have to identify it in the context of the question. That's why it's important to know what does the Y represent here and what does the X represent here. So there are 3,000 bacteria at the beginning of the experiment. Now, when time is involved, words like beginning, initially, what do they mean? So in question with time, words like beginning or initially will mean what? Time is 0. So basically they are referring to value of X being 0. Okay, so that's something to have in mind. So they're saying when time hasn't started counting, when time is 0, there was 3,000 bacteria. So that was the value of bacteria. Okay. Use KT, so use what? This function here to do what? To find the number of bacteria. So we are looking for value of Y. Therefore, they give me value of X, isn't it? After 1 hour. So that's my value of X, and after 2 hours. So I need to find two value of Y's, and in both of those cases, they gave me the value of X. So what does that mean? I'm replacing X with those values. My first value is 1, my second value is 2. So we are writing 3,000 multiply 2.72 to the power of 0.5 multiply first value is 1 and the second value of X, again 3,000 multiplied by 272 to the power of 0.5, and that multiply by 2. We put that in the calculator and we get, with power of 1, we have 4978 to the nearest whole number, and then 8160. Okay, let's have a look at the second part here. So after n hours, so what is that? Number of hours, that is the value of X that they are referring to. Give me n. There are at least 35,000 of bacteria. So what is that value of Y? 35,000 of bacteria according to our function. By continuing the pattern above, otherwise find the smallest possible value of n. So basically we are looking for X, they gave us Y. Okay, let's do that. Let's replace that. So in place of Y, we are putting the value of Y, which is 35,000. So let's do that. So we are writing 35,000 equal 3,000 multiplied by 2.72 to the power of 0.5, and then we have, that's where we have our n. So how do we solve that? Where is our letter we are looking for? It's here. And what is that? That is my power. Then what is that? This is a number that is taken to that power. So that means I have the base and I have the power. Now, what I should have normally in this type of calculation is that when I have a number that is taken to the power, I do that calculation, the multiplication, because that's what it is, and the outcome of that we get will be product. When I am looking for power, what do I use in maths? What do I say? Or how do I write that sentence? I am looking for power. We use log. We are saying log. That means I am looking for power because I am looking for this power. If I have this value, I can have value of n. So I need to know what is the base and what is the product. And then when I put that in the calculator and press equal, that will give me the power I'm looking for. Now, in order to apply that, I cannot have this number. On one side of the equation, I need to have just base and power. Once I have that, I can go to the next line of calculation. So the first thing I need to eliminate is that 3,000 here, which is multiplication. How do we eliminate multiplication? By dividing and dividing both sides of equation. So that means I am left on this side of the equation with a fraction. We can put that in the calculator and find the value or not. It doesn't matter. That's not our final answer. And we have 0.5 n. So now I clearly have, that's my base. That's the number that is taken to this power. And this is the product, meaning outcome of that multiplication. So now I can say, I am looking for power of what base? 2.72 of what product? 35,000 divided by 3,000. And I put that in my calculator, and that will give me the power, which is what? 0.5. N means what? 0.5 multiplied by n. Now I just need to deal with one more item here because I need n, not n multiplied by 0.5. How do I get rid of multiplication? Always the same, by dividing and dividing both sides of the equation. So we can put that in our calculator and get our answer. Now don't forget, in your calculator you have to look for the button that has those squares, because that's what you should see on your calculator. That's where you put the base, in this case 2.72, and that's where you put your product, in this case my fraction 35,000 divided by 3. So that's how we put that in our calculator. So in this case, when we put all of that in our calculator, we get 4.91, the value of n. Now, let's look at the terms and conditions. They are telling us where n belong to n. What does that mean? If we are not sure, we go to page 23 and we check our set. So natural numbers n, they are whole positive values. So value of n I'm looking for cannot be a decimal, cannot be a fraction. So what is the question I'm looking for? They are saying that there are at least 35,000 of bacteria. So could be more, but at least 35,000. So then I am asking myself a question, well, is it 4 that will give me that answer, or is it 5 that will give me that answer? How will I know how many bacteria do we have? Well, I know I have a formula for that, isn't it? So that's what I do. I put in my calculator 3,000 multiplied by 2.72 to the power of 0.5 multiplied by 4, I get one value, and then I do the same, but this time to the power of 0.5 multiplied by 5. And then I can clearly see that this is the one that has more than 35,000 of bacteria. This one has less. So I know my value of n is 5. Yes, that is difficult if you have never done that before. However, once you get hang of it, it's actually not that bad.